You've probably heard a lot about the promise of quantum computing, right? But have you thought about the threat? Today, we're diving into something called the quantum shift and why it might just be one of the biggest challenges our digital world has ever faced.
So, to really get a handle on this challenge, we have to clear up one major misconception about what makes these machines so powerful. And I'm willing to bet it's probably not what you think.
I mean, it's the natural assumption, isn't it? A new generation of computing that just does what our current computers do, but at lightning speed. It seems logical, but it doesn't really capture the whole picture.
And this is the absolute key. The danger isn't simply about speed. It's about a fundamentally new approach to solving problems. They don't just run faster. They operate on a completely different set of rules, which lets them tackle problems that are, and I mean literally, impossible for the computers we use every single day.
Okay, so they think differently. What does that actually mean? Well, let's get specific. It really all comes down to the power of a few special quantum algorithms. We're going to look at two of the big ones that have security experts intensely focused, Shor's and Grover's.
And look, these aren't just some abstract theoretical ideas. They are concrete mathematical procedures that, when you run them on a powerful enough quantum computer, could completely unravel digital security as we know it. This is where all the urgency is coming from.
So here you can see we're dealing with two very different kinds of threats. Think of Shor's algorithm as the ultimate master lockpick. It doesn't just try every single key. It finds a hidden mathematical backdoor in the encryption we use for everything, from bank accounts to government secrets. Then you've got Grover's algorithm. This one is more like a super guesser. It doesn't break the lock outright, but it can try combinations so incredibly fast that it dramatically weakens things like passwords. So you've got one, a targeted strike, and the other, a brute force attack on steroids.
So, what this all means is that this threat isn't some giant tidal wave that affects everything equally. No, it's much more specific, which honestly is what makes it so dangerous. This creates what our source material calls an asymmetric future.
This quote really gets to the heart of it. A quantum computer is not going to make your video games load faster or your spreadsheets calculate quicker, but it could be able to crack the very encryption that protects the entire global financial system. It's a targeted transformation, and it's focused on very specific, high-value problems.
And what are those high-value problems? Well, they're basically the pillars of our modern world. We're talking about the security protocols for all of our private communications, the data stored by big companies and governments, and all the critical infrastructure like power grids and communication networks. These are the areas most vulnerable to this asymmetric shift.
Now, hearing all of this, it's pretty easy to feel a little bit of doom and gloom. But the goal here isn't to create panic. It's to underscore the need for a clear-eyed, proactive strategy. The term the experts are using is post-quantum readiness, and it's exactly what it sounds like. It's all about acknowledging this shift is coming and doing the hard work now to build new quantum-resistant security systems. This isn't about hype or fear-mongering. It's just about smart, necessary preparation for a technological change we know is on the horizon.
And this brings us to the final, critical takeaway from all this.
I want to repeat that because it's really the core idea here. The future is not coming slowly. It is arriving asymmetrically. Change isn't going to happen everywhere all at once. It's going to happen in those specific, critical areas that can be broken by quantum algorithms, and it's probably going to happen a lot faster than we expect.
And that leaves us with the final question, doesn't it? We know the challenge, and we know the strategy is preparation. But, knowing and doing are two very different things. The fact is, these quantum lockpicks are being designed right now. So the question we all need to ask ourselves is, will we build better locks in time?